Okay? Now, second thing. The second clue as to what's going on inside of the planet, or any planet, is something that won't immediately make sense. It's by looking at a particular surface feature. And that surface feature you can see right here. You guys know what this kind of thing is? What's this? What's this thing? What's that? What are these? We actually started to talk about them a little bit last time. Craters. Yeah, these are craters. So one thing that we can look for to tell us what the inside of a planet is the number of craters on the surface of the planet. And in a roundabout way, I'll go ahead and put that on our list. In a roundabout way, the number of craters tells us how hot the inside of the planet is. So the number of craters tells us the temperature inside of that planet. Which is a little bit weird. That probably doesn't quite make sense, but based on the number of craters on the surface, you can know how hot the inside is. Let's walk our way up to it. Let's make that make sense, because it doesn't seem like those two things would be related at all. So first up, here we go. First up, let me ask you guys a quick question. Let's imagine we had two planets, okay? Imagine we had two planets. One of them was really big, and one of them was really small. Okay? Imagine we had these two planets. Which one would you expect to have more craters? The bigger one or the smaller one? Which one would you expect to have more craters? Actually, just to make this easier, let's just call this planet A and this planet B. Yeah, the bigger one, right? The bigger one. You would expect planet A over here to have more craters. And probably because it's a bigger target, right? It's a bigger target. But let me ask you a different question, okay? Let me ask you a different question. It's kind of the same question. What has more craters? The Earth or the Moon? What has more craters? The Earth or the Moon? The Moon. The Moon has more craters, right? And actually, look over here. Look at Mercury. Does Mercury have, here's a little surface picture. Does Mercury have a lot of craters or a little bit of craters? Is that a lot of craters or only a few for Mercury over here? That's a lot. That's more than the Earth. So both the Moon and Mercury both clearly have more craters than the Earth. Same thing with Venus here. Venus, not a lot of craters compared to Mercury and the Moon, okay? So with that in mind, what does the answer to our question seem to be? Is it planets and moons that are bigger that have more craters, or planets and moons that are smaller that have more craters? Smaller has more. At least in our solar system, 9 times out of 10, the smaller a planet or moon is, the more packed with craters the surface is going to be. That seems to be a general rule for the objects in our solar system, and which probably means it's true in other solar systems as well. 9 times out of 10, it's not perfectly always the case, but 9 times out of 10, smaller planets and moons have more craters than bigger ones. Okay, so we got to figure out why that is, because the bigger one is a bigger target. It seems like the bigger one should have been hit more because it's bigger. And here's a bit of a clue. The bigger planets and moons were hit more than the smaller planets and moons. So the bigger planets should have more craters than the smaller ones. Does it have more, or is it just spread out more? So the smaller planets, it has more. If you took any random section of that planet or moon, like if you looked at if you took a big box that was 100 miles wide by 100 miles wide, the smaller one will always have more craters in that area than the bigger one. So they're packed together more tightly here. That's the main thing. If this planet or moon was small enough, it would obviously not have that many craters, but they would still be packed tighter. Okay? So it's more like the density of the craters that's important here. But in general, the craters on Mercury and the moon are dense enough that they do have actually a higher total than the Earth does. Okay? And Venus. Now, check this out. So, what I was getting at was this. The bigger planet was hitting more. So let me put it this way. Craters are not necessarily permanent. If they were, then the bigger planets and moons would have more of them, because the bigger planets and moons are hit more. But what I'm getting at is that planets and moons can erase craters. And we'll talk about how in just a second, but for now, just believe me on this. Planets and moons can erase craters. So, which planets are better at erasing craters? Big ones like A or little ones like B? Which one of these must have been better at erasing craters? A or B? The big ones like A are better at erasing craters. Okay? Okay, so this is all a long walk to talk about temperature, so we're getting there. So check this out. Even though bigger planets and moons are hit more, because they are bigger, they're better at erasing craters, so they're going to have less craters overall. So they can erase craters very well. Now, how does a planet erase craters? Well, don't worry about planets at all. Imagine there was a crater outside right now. Imagine there was a crater outside, and I wanted to make a parking lot right there, because USA, we make parking lots, right? There's a crater outside, I want to make a parking lot there, and I hire you to make my parking lot. And you guys are like, oh no, there's a crater here. What are you going to do? How are you going to get rid of that crater in order to make that parking lot? What are you going to do to that crater to get rid of it? Don't overthink it. Yeah, you're going to fill it up. You're going to fill it up. It's going to fill up with dirt and rock, right? We're going to fill it up with rock, right? So let's think about this. How could a planet naturally fill in a crater with rock? How could it naturally fill in a crater with rock? How could a planet do that? And there's actually a few ways it can. So I'm going to guess you guys are going to give me a few of them. But you're probably going to forget the most important one. So that's a way. Good. So you guys said gravity and rock slides. So yeah, if things fall down, gravity's going to naturally... Erosion, essentially, is what you guys are talking about. Wind erosion, water erosion, and just gradual falling down of rock. That'll all help. But if that was the only thing, if the stuff you guys are mentioning there is the only thing, then planets wouldn't be able to erase them as fast as they are. There's another way that a planet could fill in a crater very quickly. By filling it in with, instead of solid rock, with liquid rock. What's another word for liquid rock on the surface of a planet? What's another word for liquid rock? Lava. Yeah, lava. And what does lava come out of? What does lava come out of? Volcanoes. Okay, now we're getting somewhere. Check this out. If there was a bunch of craters around, and a volcano popped up near those craters, what's going to happen to those craters when that volcano erupts? What's going to happen to those nearby craters if lava starts coming out of this volcano? They're going to get filled in with lava, right? They're going to get filled in with lava. And when that lava solidifies, you wouldn't even know that there was a crater there ever, right? The craters are just erased. Another good way to get rid of a crater is an earthquake, right? An earthquake. If there's a crater here and an earthquake shakes everything, it's going to disrupt that crater and erase it also. So instead of erosion, let's focus on these kinds of things. Another one would be plate tectonics, which we'll talk about when we talk about Earth. But plate tectonics means parts of the Earth sliding around, and sometimes part of the Earth slides on top of some craters. All of that stuff together is called geological activity. Geological activity. And all geological activity means it's any way that a planet reshapes its own surface from the inside, essentially. It's any way that a planet reshapes its surface from the inside. And again, the most common ways, the most common type of geological activity in our solar system is volcanoes. So let me just restart this. There we go. Volcanoes. But there are also earthquakes. And plate tectonics. And again, if you don't know what plate tectonics are, don't worry. We will get to that when we talk about Earth. Okay, so for now, let's just focus on volcanoes. That's the main type of geological activity in our solar system. So here's my question. If volcanoes get rid of craters, did planet A or planet B have more volcanoes? If volcanoes get rid of craters, did planet A or planet B have more volcanoes? A. Okay. Oh, some people are having some volcano experiences of their own down there. Yeah. Yes, planet A would have more volcanoes, right? Now, check this out. That means if we put all this together, in general, bigger planets must be able to have more geological activity because volcanoes, right? Bigger planets must have more geological activity in general. And even in the exceptions, if we find like a little planet or a little moon that has only a few craters, then that means it must have a lot of geological activity. So basically, less craters means more geological activity, more volcanoes, okay? Now, let's go one step further. If you, don't overthink this, if you're a planet and you've got a volcano and lava is coming out of that volcano, what must you have inside of your planet? Don't overthink this. If you've got a volcano on your planet and lava's coming out, what must there be inside of that planet? I think you guys are overthinking this a little bit. There's got to be liquid rock inside, okay? There's got to be liquid rock inside. If there's lava coming out, if there's liquid rock coming out, then there's got to be liquid rock inside. Some of you guys are thinking a couple of steps ahead. Now, check this out. If you have liquid rock inside of your planet, what temperature is it probably like inside of your planet? If there's liquid rock in your planet, what does that mean about the temperature inside your planet? It's gotta be hot, right? Yes, it's gotta be hot. So that means the number of volcanoes on your planet should give you an idea of how hot the inside of the planet is, right? So more geological activity means that the inside of your planet is hot, right? Yes, right. Now, check this out. Here we go. Let's put it all together. Less craters means more volcanoes must have been on that planet. More geological activity is on that planet. But more geological activity means hotter inside. So, bum 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 bum. Let's look at these two planets one last time. Planet A and Planet B. Planet A and Planet B. Which one is probably hotter inside? Which one is probably hotter inside? Planet A or Planet B? Let me ask you a question again. Let me ask you it a different way. Which one of these planets probably had more volcanoes? Which one of these planets probably had more volcanoes? A, right? So if A has more volcanoes, which one of these planets is probably hotter inside? If A has more volcanoes, which one of these planets is probably hotter inside? It's A, right? It's A. So don't worry if you got that wrong. It's kind of a backwards kind of way to think about it. But having less craters means you had more geological activity, so you must have been hotter inside. So let's go back to these planets right here. Check this out. Here's the planets from our solar system. Here's the terrestrial planets plus the moon. The Earth. We do not have that many craters. We do have some, but we don't have that many. So is the Earth hot inside? Is the Earth hot inside, according to this? Yes. How about Venus? How about Venus? Venus also doesn't have a lot of craters. Is Venus hot inside? Yes. Yes. Okay. How about the moon? Is the moon very hot inside? No. Same thing with Mercury. Mercury is not that hot inside, right? It's not that hot inside. Lots of craters. Now, okay, let's think about Mars. That's the last one over here. Mars has more craters than Earth, but less craters than Mercury and the moon. So what does that tell us about Mars? What does that tell us about Mars? Yeah, it's a medium size. So essentially what happened on Mars is right now, Earth has volcanoes. We have active volcanoes, right? We have active volcanoes. Same thing with Venus. Venus has active volcanoes. So we're constantly erasing craters. But Mars is not as big as us. So it wasn't able to retain heat as long as we have been able to. Mars used to have volcanoes, so it was able to erase craters for a while, but it has since dried up. It has cooled off. Because of its medium size, it was able to have volcanoes for a while, but they've all turned off. It has cooled down at this point. Mercury is very small. It was really not able to retain any heat, so it never had a chance to have a lot of geological activity. So that's why it has the most craters of any planet, okay? And by the way, where'd all this heat come from? Well, when we learn about the history of the solar system, we'll see that all of the planets started off with a lot of heat. But since they formed, they've been losing heat inside, right? Since the planets formed, they've been losing heat inside. And here's a question I have. Why is it that Mercury lost so much heat so fast? Don't overthink it. There's a pretty simple reason. Why is it that the insides of Mercury lost so much heat so fast? It's because it's small, right? It's because it is small. And it's important here when we're talking about temperature right here today, I'm talking about internal temperature, not surface temperature, okay? I'm talking about the temperature near the core of the planet, which has nothing to do with the sun. The sun's heat only heats the surface of a planet. So the surface of Mercury is very, very hot, but that can't make volcanoes happen because it's internal heat that we're talking about, okay? But yeah, bigger planets are able to hold on to their heat for a long time. Smaller planets and moons they cool off very quickly, okay? So it's just kind of like, it's like cooking, right? Imagine that you cook a turkey and a meatball. Earth is like the turkey. It's going to stay hot for a long time after you take it out of the oven. Mercury is like a meatball. Mercury is going to cool off real fast if you don't eat it right away, right? So we get to have active volcanoes, so does Venus, because it's also kind of big. But because Mars and Mercury are smaller than us, they've cooled off inside. Okay? So that's the second clue.